Hello, I'm David from David's Overy Electrical, and today I'm playing with a Metrel MI3100S multifunction tester. Now, many Sparkies believe that when it comes to multifunction testers, the range starts and ends with the likes of Fluke and Mega, and mighty fine brands they are too. I've owned both in my years. However, when I was shopping around for a new tester recently, I thought I'd go for something a little cheaper and a little different. And I couldn't find much information about the 3100S, especially on the likes of YouTube. There didn't seem to be much in the way of people talking about it, so I thought I'd get one and do the talking for myself. I've had this for 2 months now, got it at the end of October. I paid £489 for it, ex-VAT, from testmeter.co.uk. I noticed today the price is £556, so it's gone up by 67 quid, which isn't too much of a surprise because when I was at Lex in September and I speaking to the guys on the Metrel stand, they were telling me that they had a discount on until the end of October, so I availed myself of that and saved myself a few pennies for a few coffees. So I've been using it for 2 months. I'm quite pleased with it. We're going to go through the most common functions of it today. I haven't been able to use everything on it, but I'll go through what I am familiar with, and we'll see if it fits the bill for anybody else. Let's have a little walk through around the equipment, bit of equipment here. We've got this slidey door on top, and underneath here we have a recharge port because it does come with rechargeable batteries. We have a PS2 port, remember them. If you're of a particular age, you might remember they used to be on the back of every computer. I'll come back to that in a minute. And we have a USB port. Now, this is the Metrel 3100S, not the 3100 SE. And as we all know from vehicle ownership, SE stands for Special Edition or Special Equipment. So this is special without the equipment. And what that basically means is the USB port and the PS2 port do bugger all. If you had the SE version, then it looks like you can plug in a Bluetooth dongle into the PS2 port or connect it via the USB port to your PC for downloading results. So although this has a MEM button for recording results, it has no MEM built in for storing them, which isn't a problem for me because I enter my data into EasyCert on my laptop on the fly anyway, so I'm not really interested in storing results for later. Nor would I particularly trust a bit of test equipment if I'd been out and about all day taking results and got home and then hoped to download it all and find it's not there. Well, that's just a bit too scary for me, so I took the decision not to go for the SE. Underneath this door here we have a rather curious port. And the reason for that port is because it comes with a rather curious set of test leads. Instead of the usual sort of banana plugs that you plug into your tester, you have this great big stonking thing that jams into the top here. And I must admit that did put me off for a while, and I didn't like the look of that. And I remember talking to the guys on the Metrel stand at Lex saying, well, you know, that would kind of put me off buying it. But I have to say it does work quite well. It's quite robust. It is a concern that if I damage my cables, then there's probably not going to be anywhere selling replacements off the shelf, so I might need to go to Test Meter again and buy a spare, and they're a few quid. So yeah, a bit of a concern there. It also means that all three cables are constantly together, which if you're doing a 2-lead test kind of leaves a redundant lead flapping around. But by the same token, I have found that you get less entanglement with them. It just seems to come out of the box quite nicely in one go, so to speak, without you having to try and get an individual lead out and detangle it from the others that are in the box. So that does work quite well. I should probably quickly speak about the boxing as I've mentioned it now, because the Metrel comes with a soft case. And as you may know from a previous YouTube video with terrible audio quality, I'm not a fan of soft cases. I just don't trust them to last on the back of a van being thrown around. So out with the soft case and in with the good old Fluke box, which, as I mentioned before, does everything. I can stand on it, I can sit on it, I can walk out off the van with this as a complete diagnostic toolkit containing my probes, lock-off devices. There's a torch in there as well. Inside here we have my GS38 contact tester, a fuse finder, a plug tester, my R2 unit there, a earth leakage current clamp meter, non-contact voltage tester, my torch, a notebook, a meter key, a proving unit. It's all in that box, so you know, you come out to an RCD trip fault or something, chances are you won't need to get the toolbox off the van because all the goodies are in here. And a very magnificent case it is too. So poor old Metrel, it makes it look like I'm walking around with a Fluke, when in fact in this case I'm not. But there you go. These equipment manufacturers really do need to understand that the flute box or the robust case is the way to go and not the soft case. Moving back onto the tester here, let's have a little look around the back. I'm just going to undo the screw at the rear here to expose the fuses and the rechargeable batteries that come with it. So these are 2000 milliamp hour nickel metal hydride batteries, 6 of them, AA size, nice and easy to replace if they start failing. There's no proprietary battery pack there, and I can either charge them, obviously taking them out of there and sticking them in a suitable charger, or I can use the plug-in charger that comes with it in order to charge the thing up. Now when it comes to charge, I must say that it seems to hold much less of a charge than either my previous Mega or Fluke, and I think that's probably down to the backlit display, which is always on. You can adjust the brightness to a certain extent, but it's kind of always on, always there, and along with the status LEDs, which we'll look at in a minute, that does tend to perhaps eat up the batteries a little bit. Although, you know, it's not too bad. I recently performed a commercial ICR. Took me about a week, and it still at the end of the week had plenty of juice left in it to roll over into the week afterwards before I needed to worry about sticking it on charge again. But I do find that, like I say, I'm charging this more perhaps than I would have done with my previous Mega or Fluke testers. So then, enough waffle. What we're going to do now is get the old test box in that we played with in a previous video, and we're going to run this through a few tests to see how well it works. Okay, first of all, let's have a closer look at what we've got on the front interface here to play with. We obviously have our test button and select buttons, and we have a rotary selection switch. Now, again, when I was looking at the Metrel stand at Alex at the end of September, they were showing me a higher model of this kind of tester, which was all colour touchscreen driven. And I said to the guys, you know what, I prefer this thing. I'm an old git. I can't really be doing with navigating through menus to try and find where on earth I am. This I understand. I know exactly what I've got selected here without having to try and dig my way down into a sub-menu to find where I am and what I've got set up. So I much prefer this kind of setup. I switch it on here. As you can see, it does a lamp test, red light, green light, and the display comes up. A nice, clear, bright display it is too. You can alter the brightness. If I push that, you can see it switches between light and dark. Let's go dark because it seems to work just as well on the camera. And I probably do need to charge this thing. I probably should have thought of that before I started waffling on today. So I'll take a little tour around the dial and see what we can do with this thing. And obviously we can start with settings there, where we can set the language. Set which standards we're working with for RCD testing. We can set our Z factor. I've got it set to 80%, so to take into account the fact that I'm going to be doing most of my testing at near a room temperature. And we can initialize the settings there. So there's not a lot of settings on here. If we had the 3100 SE, there'd be far more settings to do with date, time, and goodness knows what else, probably Bluetooth setup and that sort of stuff. But it's a lot more simpler on this particular model. And the first item on the rotary dial, which is one I haven't played with yet, is Earth spike test. So that's your 3-lead Earth spike test. Now, I've not had cause to do that in the last couple of months, but if I'm just going to point out we've got a help button here. So if you're there thinking, well, I'm not quite sure how we do this test, it will come up with a little pictorial display on what you should be connecting where. And this is showing me that my 3 leads, live, earth and neutral, should be connected to the 3 reference spikes in order for it to come up with a earth spike impedance. So let's come out of that. And obviously if I were to undertake that test, it would give me the results here, and it's telling me what probes should be connected, and this button here, or this icon here, will show me when a test is either being undertaken or paused or whatever. So at the moment it's ready to play, if you like. It's got the playback symbol there. So we'll have to skip over that because I don't have spikes on hand to test it with in the office here. But never mind, we can always switch to the next test, which is our low impedance test. Now then, this is where it gets a little bit interesting. I'm going to try and pop that up. I'm going to just adjust the camera. Okay, so we've got the tester set up now so that the camera can see both the dial and the display. And we're going to start with our low ohm setting on the dial. And first of all we've got set is continuity. So this is a straightforward continuity test if you want to know whether your two wires are connected together or not. We can see by the display that it's going to be using live and neutral. So for, protective earth, it doesn't matter what that's doing, that's not part of this test. I've got it set so that 20 ohms is the upper limit, but I can scroll through and change that limit to something else with the up and down keys. I'm going to leave it on 20 because that's fine by me. And then we've got the buzzer set so that it should make an audible noise if the detected resistance is within that parameter of 20 ohms. So I'm going to take my brown and blue, my live and my neutral, and before I connect them together I'm going to press test to start the test. Now you notice you've got the playback button there. If we press test now, it turns into an egg timer, and we have a red light to show that we currently have no continuity. We are off scale high because the cables aren't connected together. So we are over 1999 ohms, we have an X on the screen, we have no noise coming out of the thing, and we have a red light. Now if I connect them together, there we go, there's our continuity noise, we have 0 ohms, and we have a tick and a green light to show that we are now within our parameters. So the test is running continuously. I don't have to hold down the test button. As I make or break those connections, the tester will react accordingly, and I can stop the test by pressing escape. There we go. You can see next to the playback button there is a little button that, or a little display that says cal with a tick in it. That's just showing that my leads are calibrated, they've been nulled, and I can calibrate them if I wanted to check calibration by connecting them together, as I will do with all three leads now, and pressing the cal button. And it will go through a calibration procedure and just confirm with a little double beep that we are calibrated and clear. So if my cal error shows across there, I know I need to reperform the calibration technique. The cal button and the help button are built in. I can hold down help to bring up the help menu, and again it gives me a pictorial display of what I should be connecting to get something out of it in this on this particular test. So that's continuity. Now there's more we can do on the low ohm setting. It's not just straightforward continuity. If we start scrolling up, we can go through what will be listed on a schedule of the test results. So we have R1, we have Rn, we have a little R2, we have R1 plus R2, we have big R2, and we can record values for all of them. Now those tests are all the same, and they're all performed in the same way. They're all between live and earth, so they're all between the brown and the green, and whichever test I have selected, it will come up with the same number, which is a big fat 0 in this case, obviously, because I've just got them nulled together. So why have all those menu options? Well, I presume, and I don't know, that if you were using the SE version that has a memory, you can go through and you can store the individual results for the individual tests. On this particular tester where there is no memory, it really makes no difference what you have set. So whether I have R1, Rn, R2, R1 plus R2 makes no odds at all. It's the same test performed on the same leads with the same results. Where it does start to change is where we go into the R1 plus Rn, because now we're switching from protective earth to neutral, and R low, which is again between live and neutral, so there's no protective earth in use there. So there's a whole slew of menu options to go through there, but most of it does the same stuff. Most of it is as you'd expect. Very nice. Now the next option, again I haven't had a chance to use this, is this ring continuity test. How on earth does that work, you may ask? Well, you need to buy an overpriced dongle in order to use it, and it is quite a horrendous cost. For what it does, all it basically does is you connect your probes to it, and it will perform the switching between the different connections on the ring circuit, so that you're not having to sit there and manually swap your crocodile clips over. I'll stick to the manual route, thanks very much, rather than spending that kind of money on that particular gadget. It's a shame, because if it were half the price, what the hell, I'd pick one up. I probably wouldn't bother digging it out of the box terribly often, but well, there you go. I guess, you know, if you want to use it, you can get it and use it. But it's a shame that, you know, you invest in Metrel's tester, and then they sort of sting you with this add-on gadget, which is nice, but not necessarily terribly vital to your existence. Moving on to insulation. This is more familiar territory, of course, for anybody with a normal tester or with another kind of tester. And again, we can choose whether we're doing our test between live earth, live neutral, live, neutral earth. Again, it doesn't particularly matter what you've got set, so long as you know what probes you're using and you've connected the, oops, knocked my microphone off, and so long as you've connected the right one in the right place. So we can go in and we can change it from, I've got on 500 volts, it will go up to 1000 volts, but it will go as low as 50 volts as well for your self-testing. 50, 100, 250, 500, and then back to 1000. We can also set what our upper limit is. So I've got it set to 2 mega ohm because, well, BS 7671 says 1 mega ohm is the lowest, but anything 2 you really want to be checking out, anything lower than 2 you really want to be checking out. So let's just have a little bit of a play with that, shall we? Testing's being done between live and neutral, and if I leave them open circuit and run the test, obviously it's going to come back with an off-scale high pass result of over 999 mega ohms, so it's a nice high number that this tester puts out. It tells me my reference voltage was 525 volts DC, and it's obviously within specification. Now what I'm going to do here is I'm just going to connect a 1 mega ohm resistor. I don't have anything higher, unfortunately. 1 mega ohm resistor, which is going to bring it below our 2 mega ohm upper limit, and sure enough we now have a fail result. It's showing a red light across, and the fact that we've got just shy of a mega ohm recorded in terms of resistance there. So that would be a failure in this case. Easy as that. That's your insulation resistance testing. If we go to the next one, which is your line impedance. Now I'm going to have to change my probe out here. I'm going to have to change it for the Metrel BS1363 plug top lead in order to connect it to my check tester. So we can... Okay, here we are on the live side of the dial. We're no longer dead testing, these are now live tests, and we can see we have a voltage being recorded here between live and neutral of 240 volts, and the same between live and protective earth. It's just dropped to it's fluctuating between 239 and 240. You can also see there's a spurious 1 volt between protective earth and neutral. So this shows us at a glance what kind of voltages we're looking at between our test leads. This test here, the line test, it will give us the line impedance. Now obviously I'm single phase here, so that's going to be the impedance between live and neutral, but if I were 3 phase I could take the impedance between L1, L2 and L3, or the impedances, and also the short circuit current readings. So I'm going to hit test there, hit the old go button and see what it comes back with. And it's coming back with a value of 0.71 with as an impedance, with a fault current of 325 amps. And there is a secondary function to this menu. If I scroll down, what we can do is we can take a voltage drop recording. We do that by connecting the tester at the source of the circuit, or at one end of the circuit, and hitting the cal button to take a reference impedance. Obviously we've just seen a reference impedance of 0.7 and again 0.71 because we haven't moved anywhere. And then we go to the far end of the circuit and hit test, and it will perform a test and tell us what the volt drop difference is between the reference voltage and the or the reference impedance rather, and the impedance now being monitored. And obviously we're getting a volt drop here of 0.0%, which you would expect because I haven't moved my bottom anywhere. But had this been a long lead circuit, say at one end of a garden or something, and we can take a reference impedance at one end, a reference impedance at the other end, and it will tell you what the percentage volt drop is, which is nice. If we move on to loop impedance, earth fault loop impedance. Now, I didn't mention this on the last menu, actually I should have said, you can set up what kind of circuit you're testing via the menus here. So I've got this set up as a type B 32 amp with a disconnection time of 0.4 seconds. And if I have it set up like that, then the tester will tell me that the upper limit with the 80% rule in place is 1.10 ohms, which is the value you should find in your on-site guide. If I were to scroll through and change that, either the type of breaker or the type of or the value of the protective device, then you can see it alters the upper limit accordingly. So let's pretend that we are on a 32 and run the test, and this is going to now tell me what the impedance between live and protective earth is, and 0.69, about the same as we had before. No surprises there because I haven't changed anything, and this is a TNCS circuit, so live and, earth and neutral are connected together back at the source anyway. So again, the prospective volt current is 331 amps, 0.69 is our value, and we get a green light and a tick because it's within the upper limit specification. And this is where you have to be a bit careful. You have to make sure that the settings match the circuit you're testing, or at least if they don't, because you can't be bothered to go around changing them perhaps, you have to make sure you know what your upper limits are so that you know whether it truly is a pass or fail result that you're seeing. So if I'd have left that, for example, if I'd have had that as a 63 amp circuit and run the same test, we're going to get the same number, but now it's going to show as a fail. And indeed it does, because the upper limit is now 0.55. Now, so again, you can't go by what the red and green pass and fail indicators are. You have to know how you've got your tester set up, and if you're getting an unexpected result, if it's showing a fail and you think, oh well, that should be alright, then you need to make sure that you either take those numbers into account or that you've changed those numbers accordingly. If I press the down arrow here, it changes the menu option to ZSRCD, and this is your no trip test. I'm just going to drop that down to a more sensible number again. Let's go back to 32 amps. Same test again, except now this time the neutral's brought into play, and it will tell me what the impedance is without tripping any RCD that happens to be in the circuit. Doesn't matter in this case because I'm running off my check tester anyway. And here we go, we got the same number come back, which is what I'd expect to see, so that's jolly good and very nice. Excuse me. Finally, well not quite finally, let's move on to RCD testing. We can test different types of RCD. We have A, C, A and F RCDs to play with. For those of you who do come across different types of RCD amongst your travels. And of course we've got the full gamut of tests to run, so I'm going to switch the check tester onto 30 milliamps. We're going to leave that at 30 milliamps, and I'm going to press test, and it will do an auto RCD test, which is nice because you can leave the tester obviously at the far end of the circuit, go to the origin where the RCD is based, and just keep pressing the reset button every time it trips, and then you can come back and all the results are displayed on the screen for you, so they're all available at a glance, which is nice. Now again, this is the check tester, so the numbers come out slightly different to what you would expect in a real world situation. So it's done the 1 times tests at 0 and 180 degrees, it's done the 5 times tests, it's now doing the half times test, and it does that at 0 and 180 as well, and then finally it does a ramp test at the two, both 0 and 180. So the first ramp test at 0, it's come up as 22.5 milliamps, and the second ramp test, which is at 180 degrees, it's going to come back and give us 22.5, so it's the same for both. The results do scroll off the screen, which is a little unfortunate, but if you press the help button it will scroll up and down. That's a bit of a shame because you've got all this screen space to play with. You'd have thought they'd make it so that it all kind of fits on in one go, but never mind, it works nicely and it's easy to see. And that's RCD testing. Obviously you can go into the menu there and you can change the different types of RCD. 1000, 500, 300, 100, 30 and 10. And again, whether it truly is a pass or fail, you just need to make sure you've got the right RCD selected there when you undertake the test. The final thing to point out is the voltage setting. Now again, we're single phase here, but if we were connected to a 3-phase supply, then this would show us the phase rotation as well. So I have had occasion to use that on that commercial ERCI I did a couple of weeks ago, and I can confirm it works nicely. It would probably help if I actually put a voltage on there, wouldn't it? There we go, so it's giving us our voltage from across line, across protective earth, and then there's that spurious 1 volt between neutral and protective earth, and then we've got a frequency of 49.9 Hertz. Super stuff, and that's a live test. You can see by the flashing egg timer that will just keep running until I tell it to stop or until the batteries run out, whichever comes first. So if you're trying to diagnose some funny numbers or some incorrect phase rotation or something like that, then you can leave the tester connected and running as you prat about going about your business. And there we have it. That's the pretty much the full range of stuff to show you on there. It is a very capable tester, very good. I do like the display. The red and green lights are a bit gimmicky, but well, yeah, as long as you've got or know what you're testing or got the tester set up right, then they do give you that extra bit of visual indication as to whether it's a pass or fail or not. And it's a good, capable tester. I'm very pleased with it. We'll see how it goes. How robust it is remains to be seen. Can't say I care for the blue colour much. That is a bit Fisher Price, but well, you can't have everything, can you? I prefer the yellow of a Fluke. That just looks a bit more, I don't know, a bit more industrial. I feel like a bit more of a man carrying something like that around, maybe. But this is doing the business for me, and I'm quite happy with it. So we'll carry on playing with it and see how it goes.